So today we are going to be covering application lifecycle management, the application lifecycle. And so this is the first part of the Understanding General Software Development section. It's section 3. It should be quite a fun section actually. I've prepared maybe a bit of an interesting way to show you guys some of the concepts that's less theoretical. We'll be sort of making as we go through it, we'll be developing a website a little bit to get some of the ideas across. So that should be quite nice. Let me also just see, yeah, okay, we're in the chat. But yeah, feel free to ask questions. We have done some extra reading on this topic, so you guys should have already read to the end of the understanding testing section of this textbook if you were following the extra reading that I was posting on the WhatsApp group, so hopefully you were. So then we'll already be somewhat familiar with some of these ideas, so we should be able to get through things pretty easily. So this section is very theoretical. There's not much coding. In fact, that goes for all of the sections remaining in the course. They are more theoretical than the previous two. So if theory is more of your strong suit in this kind of stuff, then this is a good time for you to be paying attention. But I also will do some programming so that we don't get rusty, to actually show you some of the concepts. Very little today because we're going to be doing mostly just covering the theory in the first two subsections. So yeah, let's go ahead and get started. Feel free to ask any questions. I think I'll get a little pop-up in the bottom right if you ask questions, hopefully, so that I actually know. Because Microsoft Teams still doesn't have like a chat overlay that I can make appear while I'm sharing my screen, which is a bit annoying. But anyway, let's just get started. Okay, so we will be discussing the application lifecycle. It's pretty simple. It's got 5 steps in this cycle. The big thing to know is this word cycle. Okay, so it's not really steps, you would say. It's more like parts. It's continuous, right? It keeps going on and on and on forever. All right, so it's not just, it's cyclical, basically. So we start with what we would call requirements analysis. Okay, and we're actually going to go through this today. We're going to go through step by step and see what each step would require us to do. And I think the important thing to understand is also the context in where this kind of thing is useful. Okay, because in the real world where we're developing large apps, it's very difficult to keep track of how the app is developing, like when lots of people are coding at the same time. But we'll see all of this as we go through this. Okay, so we start with what's called requirements analysis. Does anyone know, can anyone give me a sort of working definition of requirements analysis? What do we do when we're looking for requirements? What do we do? From your guys' extra reading, maybe some of you know a short, quick, nice answer that can get us through this first step. Anyone? Ooh, your status. Huh. That's weird. Alright. Okay, so I'll define it for now. We'll say determine the business requirements for the new application or system. We'll see examples of this later, like actual detailed examples. For now, I just want you to get an idea of the entire cycle as a whole. So when we're starting to develop a new application, the first thing we need to know is what must the application do. Okay, and that's requirements analysis. The next step is what we would call design. All right. So at this step, we do sort of planning. Okay, we do planning. We decide on architectures. A lot of these things might be new words to you, but we will explore them more in depth eventually. Okay, models. All of this would go under design. But remember that design is probably slightly more technical than what you would usually associate with the word design. Right, we're still discussing software. Okay, we're still discussing software design. We're not discussing, graphics or front-end design or anything like that. Okay. We've got development. All right, so this is implementing our design. Right, once we've created a design or a plan for how to create the system that we require, we need to actually create it. Okay, and this is what we've been covering for the whole course: is how to program. That's what happens here. The actual programming, the development of the software solution. All right. Then there's testing. Basically, this is ensuring that development works. This is the most complicated bit of this, or the most in-depth bit of this application lifecycle that we'll be seeing in section 3. And we're going to spend a lot of time discussing the different kinds of testing that exist. Okay, particularly like black box versus white box, but also the different levels of testing. Okay, what we want is not just to satisfy our requirements, but we also want to satisfy our requirements in a way that meets industry standards. Okay, because it's not just what we require from the app, it's also, if we look at our competitors, are we meeting the requirements as well as they are? Okay. And then lastly is maintenance, which is fairly self-explanatory, right? You have to actually keep everything functioning, update things. And you notice this arrow here, it's a cycle. Okay, this continually repeats forever. Okay, so let's discuss how this happens in the real world. Okay, the step, you see what you have to do. Yeah, exactly, that would be requirements analysis. Good one, Jatin. The first step, requirements, really boils down to this issue of requirements analysis. So what I want to show you is how this would happen in the real world. Okay, what actually happens? Ooh, let's see. Oh, okay, I'll handle that later. Okay, so what usually happens in the real world is you'll be working at some company, or maybe you're just a student at a university, and some faceless person in a suit will be running around. Okay, they're a business person, a business major or something. And we would often call them like the product owner or the business owner, something like that. And they'll be running around saying, I want to develop an app, but I have no real skills. Please help me, right? So this person wants an app, and it's like, maybe if you've ever sat at a Bry, there'll be a person going like, oh, you know what would be a really cool app? If we could, I don't know, a Bry scheduling app that connects to your Facebook account or something. You know, just a person who wouldn't know how to develop this at all, but just has an idea for an app and thinks it'll be easy. Okay, so there's this person, and they're running around and they're looking for help. All right, and eventually what they're looking for is another person, which I don't know, I've called here a nerd shepherd, because that's pretty descriptive for what they're doing. Okay, but more formally they're called maybe a business analyst, a project manager, okay, even a developer. Okay, lots of people can do this. A chief technology officer, a CTO, would sort of fulfill this role in certain companies. And what this person would say is like, hey, don't worry, concerned business owner. I have a flock of developers who can create your application. Okay, I have some friends. We're skilled developers, and we can actually create the app for you. Okay, and then the business owner will now be relieved, of course, and he'll try to tell you about they'll try to tell you about what this app is. What app do they want you to create? So our example here, he wants to create an app called I Levitate. Okay, it's a button that allows you to levitate. They've already copyrighted it. And yeah, he's wondering if we can get it done in 2 weeks. All right. Now, you might think this is an unrealistic example. Unironically, in my first year of university at Wits, someone came to me and asked if there was a way to make it so that a phone could levitate. They actually asked me that. Like an app that would make your phone, like when you dropped it, so that it would stop on the ground before it hits the ground. This, if you know anything technical, you would know that this is totally impossible to do, right? Totally impossible. So, so this sounds unrealistic, but this is actually an example that I've heard before. All right. So, yeah, it is usually totally impossible. That's the real thing. So that's the first bit of requirements analysis. You get like this person who has some idea for an application, maybe it's even new. The first thing is to establish whether or not this idea is even possible, whether or not we can even do it. And after that, we can start discussing things in more detail. All right, so cool. The main thing is that we want to translate from the the product owner, the faceless person in the suit, they have some gibberish, right, about what they want, some app idea. And we need to translate that app idea into specific technical requirements, something that's actually creatable, something that we know when it's finished. Okay, so what I've got here is I'll have a few lines that will appear here, okay, and they'll be what the product owner asks us, okay, what the product owner says, okay. And on the right here, I want you guys to help me decide what the analyst should actually hear, okay, what the analyst should know from what the product owner says. So for example, what if a product owner tells you, okay, a business owner, whoever, a partner, they come to you and they say, hey, you know, we want you to be able to upload videos to our site. So they just tell you that sentence. That's the first sentence they tell you. You're in a meeting and they say, we want a site to which you can upload videos. Okay. You, as a technical person, even just taking what you guys know so far, what would you respond to this with? What would you actually hear? What do you think are some of the things that we would require if we were trying to make that site? And yeah, I'm going to give you guys some time, but we hear this first line. We want you to be able to upload videos to our site. What do we, as analysts, as developers, what do we immediately know? Okay. Yeah, it's possible. Good one, Jatin. That's a good place to start. We can definitely create a website to which you can upload videos. So this is already pretty realistic. What do we already know as well? More technical than what they're saying. They said site. Okay, you guys know what a site is. What do we immediately know? If you want a website, what do you need? Can you guys give me some examples? What would we need? There's many other technical things that we have, right? They've told us, that singular sentence has actually told us quite a lot. Can you guys help me break down what it tells us? What do we immediately know? Any ideas, guys? Any ideas? I'll give you time, because I know we have to wake up. We're doing warm-up. What do we know? We want to upload videos to our site. What are some interesting ideas already implicit in that? Maybe I'll show you guys the first example, my analysis of it, and then we'll see what you guys can say about the second one. Let's do it that way. Okay, so immediately what I hear, instantly from that, and you can see how specific it gets, right? Even just from this, it's like, we want to be able to upload videos to our site. We immediately know, okay, we need a fast, scalable server. Okay, it's very difficult for us to actually serve videos. Videos are large, they're difficult to handle, they take up a lot of space. So yeah, you would need a pretty fast server. It's going to be pretty expensive, I could tell you. We would need to support multiple resolutions, right? That's a simple thing already, right? Standard definition, HD, 720p, 360p, 1080p, all of these different sort of resolutions we would have to consider. I would immediately start asking questions about, like, what video formats do you expect to support, right? They said we want to upload videos to our sites, and I'd immediately be thinking, okay, videos of any length, right? Being able to upload 10-second videos to your website is very different from being able to upload 2-hour videos to your website. Okay, and I would also know that I would warn them. I would say this is already a super expensive thing to be doing. Okay, to be hosting videos online, especially just any video uploaded by anyone. That's an expensive thing to be supporting. Okay, so just from this singular line, all of this, and this is actually limited. There's way more things you could say here, way more things. But this is the kind of thing that the analyst would be thinking. Just from that singular sentence, you can already start thinking about all of those different things. Okay, so like this is like quite a difficult job, actually, translating from just these kinds of broad sentences to actual specific technical requirements. This is a whole career. You can make a career of this. Okay, so I give you one extra sentence. What if they now say, so they told us we want you to be able to upload videos to our site, and the second thing they say is your friends must be able to view them. Your friends must be able to view them. So after hearing that, what questions do you as analysts and developers have to ask immediately after hearing the second sentence? What are we wondering? What do we start thinking about after hearing that second sentence? And you guys can get as technical as you like. Probably a lot of the answers that you guys give would make sense. Precisely, it's like, okay, cool, so now we need user accounts. They haven't noticed, the two sentences they gave us, they said we want you to upload videos, and then they say your friends must be able to use them. They never mentioned user accounts, right? But we know already from like being technical about it, we would need to be able to define what a friend is. Okay, exactly. You would immediately start asking questions of accounts, right? So do you need a username? Are we going to link accounts to email addresses? How many accounts is each person allowed? Like, must we make it so that there's a limited number or something? Like, how are we going to be restricting these things? Exactly, you'll need to be able to add friends. If you can add friends, you'll need to be able to remove friends. There's also this whole issue of like just defining what a friend is, right? Can not friends view your videos as well? Like, what are the permissions on that? Do we now need to support things like features? Is that the sort of line that they're thinking down? But you can see that even just from these this is one sentence and a half, we've already expanded this website into a huge number of technical requirements, right? And we could go even more technical than that. We know that it's a site. That means that you're going to need a domain name, right? You have to buy it. You're going to need a specific host. Like, you can go with AfriHost, Amazon, Google. You can get any number of different hosts to host your website. And yeah, there's numerous things that we're already thinking about, right? Cool. And then so the examples that I gave here, this is just fairly simple. I didn't do them all right. I said, yeah, we would need a relational database. Okay, we now need also sort of some kind of dynamic web design, right? Because like if I click the add friend button, okay, like if you were just uploading videos to a site, right? You just have a page and you visit it and there's just a bunch of videos on the page. Nothing needs to change, right? Like, you can upload a video, reload the page, and then your video will be there. That's a fairly simple website. However, now that you have an add friend button, when you click add, you don't want the whole page to refresh every single time, right? So like when you click add, you'll want it to just change that add button to remove, but making it so that just the button changes and not the whole site refreshes, so that it's no longer static. That's actually a huge problem. It's quite difficult to get that to work. Okay, so we immediately, even just those kinds of small technical things that the person speaking is not even thinking about. Okay. So yeah, we need a relational database to be able to say friends are to relate friends with one another, like relate accounts as friends. We would also have to immediately start asking this question: what is a friend? What do you even mean? Okay, this is from 1.5 sentences. We've broken it down into this and more. Okay, next they say on mobile devices and the website. Okay, they say on mobile devices and the website. So now what are you guys thinking about? So we've now got 2 whole sentences. So they're saying they want to be able to upload videos to the site. Your friends must be able to view them on mobile devices and the site. Okay, so what are we thinking about now? So only mobile devices? Precisely, we could be asking those questions. They say on mobile devices and the website though. So maybe they're saying like maybe this is suggesting desktops as well. But you can see that immediately, like the technical requirements, you have questions now, right? You want to ask them to be more specific. But also there's this question of which mobile devices, right? And also mobile devices in what way? Do you mean mobile applications? Or do you mean the internet? Okay, like, is it a mobile browser enough? Yeah, exactly. You now need an actual app. Now that's like this whole other thing, because previously they said the site, right? But by adding this extra half a sentence, they've now opened it up to the point where we no longer just need a site. We now need an Android application and an iOS application. Okay. Yeah, exactly. You would need to optimize for specific different devices now. That's true, because mobiles have smaller screen sizes as well. Make the website mobile friendly. Precisely, we would need even more dynamic web design, responsive web design. Pretty difficult, particularly if we don't have a mobile application. We would need to design our website to also work on phones. Yeah, perhaps we would have to scale things down. That's true. So what I said here is, cool, now we need a web backend for iOS and Android applications. So how this usually happens, if you don't know what I wrote there, web backend for iOS and Android applications, is how this would usually work is you have an Android app and an iOS app, and you have a website, right? So you've got these three different things. Think of YouTube, for example, right? It has an iOS app, Android app, and its website. Okay, but YouTube, or the database for all three of those things is the same. Okay, so like there isn't three different databases. You can see like when you access it on your iPhone or on your Android phone or on your computer, you get access to the exact same videos. Your accounts is exactly the same, right? So what's happening there is all three of those different devices are connecting to the same database. But that's quite difficult to do, to be able to support that kind of interaction. Okay, so immediately we know that that's now the case, right? And immediately from just saying that we want mobile devices, suggesting that we want mobile applications, we're now working in at least three different programming languages, right? We would need something like Swift for iOS apps, so you use a language called Swift to make iOS apps. You would need Java for the Android applications, and you would need then some web framework, something like Django, which is Python based, or ASP.NET, which is C# based, to develop the actual website. Okay, so immediately just from these three sentences, I've broken it down into what languages will we need to develop in, what kind of servers would we need, what kind of all of the different requirements, just from two sentences. Okay, so this is what requirements analysis is, guys, where we're given like this vague terminology that doesn't really mean anything, right? It doesn't really translate into something real, where and then you translate that into something that a person can actually program. Okay, so that's the process of requirements analysis. And yeah, you can see that this is actually quite a difficult task, because it's quite difficult to be able to, you have to take what the product owner is saying and try to understand their vision, like you have to actually translate this into something that will allow a developer to actually create what they're suggesting. It's very difficult to translate between these two things. So that's what I want to show you guys with this little example here. Okay. So that would be the first step of the application lifecycle. But then also remember that it's more like the first part of the application lifecycle. Okay? Because this is a continuous thing, right? Like when we finish developing the application, the product owner could come back to you and say, actually this whole friends thing is pretty silly. I would rather have a subscriber system. So you subscribe to particular people who upload videos, right? They might come back and say that at the end. And then you have to go through this whole requirements analysis process again, okay? Because your requirements would continually change. Or like they'll come back and say, hey, we no longer want to support iOS, or we no longer want to support Android. Okay, so stuff like that would require you to change a lot of these requirements. And you have to be very specific, much more specific than we were here. Cool, so the next thing to discuss in requirements is that they're split into two different groups. Okay, so to make it even more specific, you can see in our little example here, I was discussing things like what is a friend, right? So this is like saying, like what is the actual development? What is the function of this friend when you say friend? I also ask questions like what video formats do you want to support? You can see that's quite technical to what they're actually discussing. But when I say something like fast scalable server, this word scalable, you wouldn't necessarily say from this first sentence that you would need a fast and scalable server, right? You would, if you want this app to be successful, you do need this. but you can see that it's not essential to making the app function, right? Like it's not essential to what the app is actually doing, right? I am able, even if our server is not fast, if it's not scalable, I could still upload a video to it, right? So I would still be able to achieve the function that the product owner was asking me for. I would still be able to upload a video. I'd still be able to add a friend. It would just be slow, like very slow, because you're now playing a video from a slow server. That's cheap, but it's also slow. Okay, so you can see that there are things that are functional, right? Like being able to add a friend is the one that Soham brought up. But then there are also things that are sort of non-functional. Okay, so those are the two groups that we split requirements into. All right, we have our functional requirements. So this is like specifics regarding what the system should actually be able to do, right? Like it must actually be able to upload videos. Okay, it must be able to add a friend. It must be able to scale down the videos for different kinds of devices, like to resize them and stuff like that. Okay, and then we have non-functional requirements. Okay, these are sort of quality requirements. So like scalability, maintainability, testability, security. Okay, and the trick on how to remember what a non-functional requirement is and how to remember how to give examples of non-functional requirements is that we just say anything ending in ity, basically. It's a pretty silly rule, but it is pretty true. And it's not, so not all non-functional requirements end in ity, but most of them do. Okay, right? And you can definitely reword them. Like affordability is a non-functional requirement. Scalability, security, maintainability, testability, and you could go on. I'm sure you guys could think of many examples. Okay, so yeah, we've got these functional and non-functional requirements. Okay, guys, so those are what we split when we're performing requirements analysis. We think about it in those two ways. Cool. And that's basically it for what you need to know about requirements analysis. So the big thing I would say, do know how to give some examples of non-functional requirements. Okay. And yeah, that's most of what we have to know in that sort of bit. Okay. No questions, I assume, on that. It's a pretty nice idea. I think that's quite an interesting job to go into. Business analyst, it's quite cool. And business analyst, and yeah, there's a lot of sort of things that you can get done in this. Okay, so the next big part of the application lifecycle is design. All right, design. So there are a couple of things that we have to consider under design. I listed three. So we had planning, models, and architecture. Okay. So big one, architecture. This is sort of a technical blueprint of the system, but it's difficult for you guys to understand what that means. Okay. So what I want to show you is just examples of architectures that you might understand. Okay. So this is like saying, why might we have an architecture? Well, if we don't have picture it in terms of building a building as well, right? Like you create a blueprint, you get an architect to create some kind of blueprints for your building, right? Picture what would happen if you weren't building according to that blueprint. You would get a builder to come on the site and they'll say, hey, I'm here to build a wall. And they'll just put up a wall somewhere, right? And you could imagine how chaotic it would be. Like maybe a plumber would arrive on the site and they'll just lay down some pipes somewhere and just trust that the house gets built around them. Okay, so we create this blueprint so that when new developers come to the site, like if a new developer comes and they want to add the friend, for example, they want to add some system that allows you to add friends, they would know where to put it and like what way to structure it. Okay, so I'll give you two examples of architectures that might sort of we can't discuss architectures in too much detail, but I would rather not just gloss over it like the textbook does. So I want to give you two examples of fairly popular architectures that you might be familiar with from the applications that you use like each day. So here on the left, we have what's called an event-driven architecture. Okay, you guys know what events are. We had a lecture on events and delegates, maybe three weeks ago, I think it was, 3-4 weeks. So you know what an event-driven architecture is. Okay, so, or you know what an event is. All right, and so an event-driven architecture is just when you add something to the app, there's a lot of different ways you could do it, right? Like there are a lot of different ways I could upload a video. So for example, when we did the event, when we learned about events and delegates, I hope you guys remember we had the content creator, some subscribers to notify, and our system, right? And we were programming a way to relate these things together. And you guys have already seen 2 ways of doing this, right? In the first way, we didn't use events. Okay, it did work, but we didn't use events. We just used normal methods, our normal classes, all of these normal ways of doing things, right? And then I showed you the event-driven way to do it, to instead say, when we upload a video, we announce, okay, we announce that we've uploaded a video, and that's what this event bus is, okay? So let's say this event producer here, this first one, was a video uploader. So it would announce that it uploaded the video, so it would throw onto the event bus, it would say, hey, I uploaded a video. Later on, some other people would see that, oh, a video was uploaded, and then they know what to do when a video is uploaded. Okay. So an event-driven architecture says, if you're coming to add something to our application, add it as an event. Okay. So just add another event. That's how we do things in an event-driven architecture. Everything's an event. Okay. And can one of you guys give me an example? What would be a website that's very popular that uses an event-driven architecture, even just from what you know now? You haven't heard me precisely. YouTube does use an event-driven architecture. And how can we see that? Well, each of these event producers might be like a content creator, right? They upload a video, and then there's a bunch of event consumers, right, who see that a video was uploaded and they get like notified and a bunch of other stuff happens. But all of the event consumers know what to do when a video is uploaded. Okay. And you can see it on the broader way like that, right? We have subscribers and we have publishers, or we have content creators and we have subscribers, right? Like you can see it in that broad way, like that's how the site works, right? You can subscribe to other people, you can upload videos, right? So there's that obvious sort of connection. But when I say event-driven architecture, it's more fundamental than that, okay? It's not saying just that there are these subscribers and publishers like people. It's saying that every single part of the system is made in that way, okay? So like when you click a button on YouTube, that's an event. It goes like, hey, this button's just been clicked, and the button will be animated in some way. The pages will switch around, right? Like all of these things are implemented as events in an event-driven architecture. Okay, so that's the important thing to understand. It's like it's more technical than just subscribers and content creators. Okay, like the actual site is programmed in that way. Okay, and you can see it makes sense that you would program it in that way, right? It's how the site works, and it's also the way it's coded. Like it's programmed in like a fundamental way to achieve what it does. Okay, we also have this other architecture. So we're familiar with an event-driven architecture now. On the right here, I have what's called a model view controller architecture. Okay, model view controller. So MVC architecture. Okay. We won't go into too much detail like this. I am interested to see if you guys could, maybe guess at a few applications that are programmed in this way. This is an extremely popular way to make websites, okay? Or basically anything. This is an extremely popular architecture. So I'm just going to describe what it does, okay? What each part of these does. So there's 3 parts. There's a model, there's a view, and there's a controller, okay? What the model does is it describes the structure of data. Okay? So it basically says, when I'm saving things to my database, this is the structure that I'm using. So one way that you can instantly become familiar with what a model is doing is it's basically defining the type, the size, the length of all of the different variables that you save in your database. Okay, so like usernames have this length. Okay, they are this type, right? Passwords have this length, they are this type. Okay, all of those things are encoded in the model. Okay, that's what the model does. Okay, so we understand what the model does. Basically, it's allowing us to translate from what the database is storing to actual code, like variables that we can use and work with and update. Okay, so that's what our model does. The view is what it sounds like, actually. The view is what the user looks at, right? So it's a template, basically. So it says, like, look, we've got a username, for example. Let me actually explain it to you in that way. If I go over to my Google Drive, for example, okay, so you can see that all of these different documents, there's a lot of them that I have on my Google Drive, are saved in Google's database somewhere, right? And like basically there's a template that says, okay, you can see all of the documents, like there's different types, right? This is a PDF and this is a doc. This is a image, another PDF. This is a spreadsheet. You can see they're all different documents, but you can see they're being rendered according to a very specific template, right? There's like the icon representing what it is, the title of the documents. There's a picture of the documents or like a preview of it, whatever. You can see that even though this is a video, right? But you can see all of them are rendered in the exact same way, despite all being different documents. And that's what the view is defining, right? So it says we've got all this stuff in our database, and it might all be of different types, and the view just defines a template for displaying that to the user. Okay, it's pretty straightforward. And then lastly, we have a controller. Okay, so the controller goes, because look, there's this template, right? It doesn't care about what documents it's rendering. If you give it a document, it will be able to add it to this list of documents that I have here, right? The template doesn't care, it'll just add it. Hopefully we can see that. And the other, and the database just has the data. It doesn't know like who can see what is it allowed to do with specific data, how does it update data, all of that kind of stuff. It doesn't care about. It doesn't know how to do it. It just stores the data and translates between the stored version and variables, right? The controller is what decides who can see what. How do we update the data? How do we save it? Like, how do I pass from the database to the view? What do I give the template so that it knows how to work with all of the different information, right? So all of those kinds of things is what the controller handles. All right, and that's a model view controller architecture. Okay, and understand what it means to use this architecture. It means everything on your website is made in that way. Okay, so I've spoiled it with Google Drive, but can one of you give me another idea? Just name some popular apps or websites that you think might use a model view controller architecture. Any of you guys have any ideas? Where might it make sense to you guys? Facebook, not a bad guess. Any other ideas, guys? OneDrive, iCloud, yeah, probably, yeah. There are some sensible guesses there. Instagram is one of the largest sites that uses a model view controller architecture. Okay, there's also TikTok nowadays is very popular. That uses a model view controller architecture. Okay, so there's lots. Okay, like this is a very popular way of developing websites, and you can see that it makes a lot of sense, right? We've got our data, we've got our templates to display the data, and we've got a thing that controls what data can be displayed when and how the data is updated, right? It's very sensible as a way to design an application. Okay, so I want to just go quickly through the last two things, and then we'll take a quick break. Okay, so we've discussed architecture a little bit now. The textbook doesn't go this in depth. It doesn't give you an example. but hopefully you can see it's like the blueprint for the system. Okay, how we develop it, how we add things to it is the architecture. Okay. The next thing is to say user experience design. All right, so this is like the more front end side of design. It's more traditionally with what you would associate with the word design, right? The architecture is quite technical, right? You don't actually see it. When you're using YouTube, you don't see the event-driven architecture. When you're using something like Instagram, you don't see the model view controller architecture. It is there, but you don't see it. So it's not typically what we would associate with the word design. However, UX design or user experience design is we do associate with the word design. Okay, because this is what design is. It's like when you click on a specific thing, it must transfer to a specific page. All the buttons must work in a nice way. It must look good. User experience design has to do with like all of that and more. Okay, front-end developers, they handle this. This is what a front-end developer, or nowadays they're more frequently called product developers. That's what they do. Okay, making sure that the user is comfortable using it, making sure everything makes sense. Like all the little help icons, you see when I mouse over this, it pops up and says more actions there. Someone designed that. Okay, if I mouse over there, it says stop sharing. Someone designed that. Okay, that's all to do with user experience design, transferring between the different pages. There is technical sides to it as well, obviously, like you have to work with the controller and stuff. And it is quite difficult to make things design responsively, right? Like if you view something on a desktop computer, it must be a certain size, right? You as the user expect that. And when you view it on your mobile phone, it must still be visible. But that process is actually quite difficult to get right. A website that looks nice on a computer and on a mobile phone, it's quite difficult. Okay, so user experience design, quite a broad thing, but basically front end sort of design. Okay. Next, I put under here as well planning. Right, I don't think the book mentions it generally, but I like this as like the more general side of design. All right, like deciding on what languages we're going to be using, because even though there are, like if you need a website, you obviously need a web framework. Okay, so that's decided for you in requirements analysis, but the specific web framework that we're using is not decided at that point. Right, like there's lots of different ones we could use. So I put that under planning. There's also this decisions about what services we're going to use. Are we going to use AWS? Are we going to use Google Firebase? All of that kind of stuff would fall under planning. Okay, so and that handles it for design. And so next we would go into development, but first we're going to take a little break because we have been going for 45 minutes now. Shall we come back at... I guess we can do a long break today. Hopefully we'll still be able to finish testing. We'll come back at 5 minutes to 4. Okay, so 15:55. Okay, so 10-minute break. Being generous today. You don't want to like TikTok. I haven't used it actually before, but it is very popular. The company that owns it is called ByteDance, I think, and they're now the largest privately traded company in the entire world. They're worth a lot of money. I'm not sure actually. I haven't used it, so. But all of these apps, they just consume so much time. But clearly people don't hate it, actually. There are some people, but clearly most people really like it, or it could never be as popular as it is. Okay, I'm just going to go and get some water, guys. I'll be back soon. Yeah, we'll start again at 15:55, okay? Yeah, Connor, yeah, Connor, yeah. But that's what people used to say about all of the internet, is that it makes people antisocial.
Yeah.
Is that it makes people antisocial. But yeah, it has become a little bit crazy now. Particularly, yeah, I think the web should be more anonymous or something, like than it is now. Too much of people's lives are now just internet based, if you like. But nothing we can do about it as long as it's popular. Get started again in about 3 minutes. But it seems that TikTok's also only popular in the younger generation. Like, my girlfriend's baby sisters use it quite a lot, I think. But other than that, I don't really know anyone who uses it, so... but that's the other thing. I would say that it should be more localized, like South African social media. Like, we should have our own sites, sort of like what China does, where they have their own search engines and stuff. Although obviously there it's because they're trying to censor, but it's owned by ByteDance, which is a Chinese company, yeah. But yeah, I think people should be wary about using all of these. I mean, I can't critique because I do it all the time, obviously. We're on Microsoft Teams now, which is American. I use Google Drive for almost everything. This is American. YouTube is obviously popular all over the world, and there's no like South African or even African version or any other version. It's just everyone uses YouTube. So yeah, need more competition. We've got too many like huge monopolies, you know, like, which obviously somewhat makes sense because you want everyone to be able to communicate, but it also means that it becomes a little bit obsessive, I think, something. Not sure. Much larger problems than we can discuss in a 10-minute break. Okay, shall we get started again? I think we should be able to finish all of testing, but I'm not sure if we're going to get much past testing, because testing is a pretty in-depth topic actually. So I think connect it, when we're discussing testing, try to connect it to applications that you use, whether it's games or YouTube or whatever. Try to think about how they would test those applications, and what kinds of problems you can have, and do share them as well in the chat when I ask you to. Okay, so the next bit technically was software development. We've been this is the bit where we actually make the system. Hopefully you guys get this bit by now, right? This is the programming, the actual development. Actually, once the design and the requirements analysis is all done, you'll be surprised how easy the development bit actually is. Like, once you've sorted out all of the DevOps, if you like, you've made the plans, you've got all the services, the actual programming of it is not the hard part actually. So yeah, cool. We might discuss this more in depth later when we talk about some other parts, but for now you guys know what the development step is for, right? It's where you actually make the system. So we're going to go right on to the second last portion, which is testing. Okay, so we've now done the requirements analysis. Okay, oh, I don't know, can you? Yeah, I suppose. I guess shall we discuss TikTok again until he's back? It's strange, I guess, because you could always make up with the YouTube video, although obviously you do want the continuity. So yeah, I don't mind waiting a bit, I suppose. Ooh, no one answered my question earlier. Are you guys going back to school? If so, when? Because I saw Roosevelt is going back on the 3rd of August. Crawford has been back for a while. You guys also going back on the 3rd of August. Okay, cool. And are you guys doing this intensive? I think it's the grades 7s and 11s, if I'm not mistaken, who are doing like this, I don't know, 1 week of like 8 to 5 school or something. Are you guys doing that as well? Is it next week, the 6th of July? Not sure. Okay. Oh well. Yeah, well, just keep me posted on the WhatsApp group, please, for when you're going to school and stuff, so that we can update the times if we need to. You guys go to 3. Okay, maybe then we could push back our lectures to like 3:30, so you can get a break between school and our lectures. So we had started at 3:30. That's what we're doing with Crawford now. So we go 3:30 to 5. But yeah, we can discuss that more then. But it's most likely August for the grade 8s. Okay, cool. And that also depends actually, because apparently coronavirus might get more serious again. So I don't know. A lot of this might change. Anyway, okay, so Connor's back. Let's get started. So testing. All right, we're discussing testing. So we've got our stages. Keep them in your head, like what's going on, right? We did requirements analysis. So some faceless person in a suit who doesn't know how to program came and said they wanted an app. We translated that into something that's actually technical and usable. Then we actually use that to design the application, design what everything looks like, what pages must go where, what buttons do we need to have, what do our databases need to look like, what languages are we using, all of that kind of stuff we designed. Then we actually developed it and we finished that quick. Okay, so we actually developed it, and then now we've got an app, right? We've developed it, but how do we actually test it? Right? How do we actually test it? So that's what we're going to see now in testing. And don't worry, guys. So I'm going to show you all of this on a real-world website. Okay, I have created a website. It's bfmta.herokuapp.com. You don't have to go there now. In fact, it's probably sleeping at the moment. But yeah, we will be actually developing this website a little bit and seeing all of these different stages come out and figuring out how all of this works. Anyway, so we're on to testing. All right. So there are a lot of ways to discuss testing. The book says 2 of them. All right. The first way that the book says is black box versus white box testing. Again, you would have seen this in the extra reading, guys. We are going to discuss it more now, obviously. But so that's why I'm discussing it at this high level first. So there was black box versus white box testing. But then there's also this lower level as well, where we split testing into 5 different levels. 4 or 5, I forget. And we split it into these levels, and each level is much more specific. So I prefer the level way of discussing it, but we're going to get this black box versus white box out of the way first. All right. So yeah, we can say that we would call these the approaches to testing. Okay, so there's 2 approaches to testing: black box testing and white box testing. Okay, the term black box, you've probably heard that before. When planes crash, you can see like the fire engine that goes to the plane, they try to find the black box, and the black box is this thing that records what the pilots were saying like during the flight, so that they can figure out why the plane crashed. Okay, so, and it also restores a bunch of other metrics about the plane. So that's the term black box in that context. But in general, what it means is just like this complicated thing. No one really understands how it works. It takes things in and it gives stuff out. We don't know how it translates from the things it takes in to the things, to the things it puts out. But that's why this black box metaphor is more to do with this idea of us not understanding it. Okay, so it takes a bunch of things in, it gives us a bunch of stuff out. We don't care what happens in between. Okay, like when I find the black box, I don't care how it works. I just want to hear what it said. Okay, I just want to hear what people said. Right, it has a particular use, and we don't care how it achieves that goal. Okay, basically you can't see inside it. Something like that. All of these metaphors apply. Okay, so what it means in this context is you picture yourself. So remember, we have an application now, right? Like we've built this video uploading application, for example. We want to test how it works. So how black box testing would work is we picture ourselves as a totally clueless user. Okay, we just log on and we see the website and we just click on things. We do what a user would do. All right. And we just document whatever problems or errors or weird results that occur. Okay. You don't also, it could be an actual clueless user, right? You don't have to picture yourself as one. You could actually be a user. You could go and find some users to test your site. Okay, that's black box testing. So it's like you don't care about how the site works. For example, when the business owner uses the site, that would be like black box testing. Because the business owner initially said, hey, I want to be able to upload videos to our site. We did a bunch of technical stuff, right? Scaling the videos, making sure definition is correct, making sure that it can render on a bunch of different screens. We did all this super complicated stuff. We take it back to the business owner at the end. He doesn't know how any of that works. He just checks, can it do what he said he wanted it to do? Okay, our faceless person in a suit that we saw on the first slide. They're just checking, does it do what we wanted it to do? Okay, so that is like black box testing. He doesn't understand how the system actually works. They don't understand how the system actually works. They're just using it and seeing if anything goes wrong. Okay, so you could see that as a beta test is a nice example. You guys know what beta tests are, right? Where you just give it to users They play with it. If anything breaks, you just ask them about it. Okay, it's a fair way to test. The other way to test is called white box testing. Okay, and it's kind of like the opposite of this previous one. Okay, as the person who made the site, as a developer, as a programmer, you know what errors can occur, right? You actually know how to break the system. You have expectations about what should and shouldn't work. Okay, and you can write test cases, or you can force errors to occur to make the tests as difficult and as meaningful as possible. Okay, so do you understand the difference between these two things, guys? It's somewhat vague. I don't like this way of categorizing testing personally, but the idea is quite simple, right? In the first case, we don't know how the system works. We don't care or know how the system works. In the second case, we know exactly how things work, and we play with it specifically with our knowledge. Okay, so do you guys understand the difference? One of them is users testing. The other one is when developers test. Okay, do we get it? Is everyone comfortable with that? No questions? Okay, I assume we're okay about it. Cool. Now, on to the better, I think better way of categorizing testing into 5 different levels. Okay, you can find these levels on page 69 and 70 of your textbook, but they're all going to be on the screen anyway. So, but maybe if you want to highlight something. So I like this way of categorizing testing. Okay, so because this way is really in tune with how you develop a website. Okay, and we'll probably be able to, we'll finish this today and then we'll probably be done. So the different levels of testing, 5 levels of testing. Okay, so the first level is what we would call unit testing. This is testing the small things. You guys know what units are, right? When we say units of measurements, it's like 1 meter or 1 centimeter, right? The meter is like a single unit, or even in numbers, right? When we have like ones, that's like the units, and then we have tens and hundreds. So like a unit is like the smallest measure of something, right? The smallest piece. Okay, that's what a unit is. So when we say, I'm not sure what the formal English definition is. Unit define. Let's just see. Might be nice. An individual thing or person regarded as a single and complete, but which can also form an individual component of a larger, more complex whole. Okay, so it's like a small component, a singular component, a complete component. Okay, so this is what unit testing is. It's testing like the small little pieces individually. Okay, so I'm actually, because we can and it's easy to do, and I want to give you an example of at least one coding example when we do this, rather than just keeping it all theoretical. What we're going to do is head over to RexTester, and we're going to program a simple example of a unit test. Okay, so let's pretend we're a developer over at Standard Bank, for example. Okay, actually, do we like Standard Bank? They're a bit expensive. We're a developer over at Capitec. Okay, we're a developer at Capitec, and we're programming the system that allows you to debit your bank account, right? So you have like 10,000 Rand in your bank account, you want to take out 9,000 Rand, we're programming the system that would allow you to do that. Okay, so let's just do this, and we're going to make a unit test to test the little part of the system that we made to make sure that it's working. Okay, so pretty simple example. Firstly, we're programming a bank account, guys. The properties, the fields that we have, we'll have like, let's say, a name or an account number, and we'll have a balance for the bank account, right? What protection level will we give to these? Where we're programming a bank account, what protection level will all of our properties and fields have, guys? Do you know? What protection level? Do you know? Saham says private, and that makes perfect sense, right? Obviously, in a bank, everything's private. Okay, you don't have any public fields. So yeah, it makes perfect sense. We'll make it private. So we'll say private string name. So we're just going to have a name linked to each of our accounts. We're keeping it simple, okay? And we'll say private double balance. Okay, something like that. I'm gonna create. So when I want to create a new bank account, I'll have to set the name and the balance, the initial balance. How would I do that, guys? What sort of member in my class would allow me to do that? Anyone know? What member would I use to create a new bank account? We have our bank account class. We need to set these fields. What would we use? Do any of us remember from section 2? Yo, Saham, you're on point. Not sure if everyone else is just asleep or if it's just that you're... Okay, yeah, so we need a constructor, right? And our constructor is going to take in two things. It's just going to take in like string. We'll say name and double principal. Okay, and we're just going to set this dot name equals name and this dot balance equals principal. Okay, so we've got our two private fields. Guys, how can... that's true too. Oh yeah, maybe if other people are... That's true. So what do you guys think? How do we access these private fields? So we've got a name and we've got a principal. They're private, so that means I can't even see my balance from outside the bank account class. How would I do that? How can I see these private things? Anyone know? How would I go about seeing these private things? There's two things. We've been doing them automatically for so long that you guys might have forgotten. But how do I like access or change or whatever? How do I access or change things from outside a class when they're private? Seems like Saham maybe doesn't even know this one. Does anyone have any ideas? What are they called? I swear, you guys would hit yourselves after I reminded you. How do we access private fields, private properties? No one knows. Okay, I'll pretend to be a student and I'll answer. Getters and setters. You guys not remember those? We've been doing them automatically for so long that might have been what was causing the confusion. Okay. So yeah, we would say we would need getters and setters. Okay, so like public string name. Again, you guys haven't seen these for so long. We've been doing them automatically, right? Like I'd put get here. So we've been doing them automatically for so long that you guys might have forgotten. Which is fair enough, but yeah, they look like this. Okay. Been a while since we covered it, so I don't blame you guys too much. But do try to remember that, getters and setters. Okay. And then we would say public double balance. And now notice, guys, I'm only adding a getter. So what does that mean? I want you guys to think about that. I'm only adding a getter. I'm not adding a setter. Because I want you to be able to see your balance from outside the account. But I don't necessarily want you to be able to change your balance from outside the account, right? So I'm only adding a getter, right? Because the getter will allow us to see it. The setter would allow us to change it, but that's why I'm not adding a setter. Okay, we don't want to add a setter here. Okay, so we've got our basic structure here. We've got a balance, we've got a name. It's private, it's very secure, and this is correct. Okay, and I can show you that. So we're going to create a new bank account. Bank account BA equals new bank account, or okay, I'll say AC equals new bank account, and I have to specify the name and the balance. Correct? I have to say, we'll say that this is Jane's bank account, and Jane has what? 10,000. 10,000 whatevers. We haven't actually specified a currency, but that's okay. Okay, and we're able to say like console.writeLine, and say like ac.balance. Okay, to print out the amount of money that the person has in their accounts, and we could say act.name to print out the name of the person who owns the account. Okay, pretty simple. But what we wanted to actually do was to be able to debit the bank account, right? So they have 10,000, and I want to be able to debit money. So I want to be able to take out money. So I'm going to create a method for that, right? So I'll say public void debit account. Okay, something like that. Now, guys, what I want you to see here is, actually, let's first discuss that. So I want the person to be able to debit their own account. What do they need? What arguments do we need in order to be able to debit someone's account? There's only one of them, I'll tell you that. In order to debit someone's account, what do we need to pass to this function? There's only one thing that we need to pass. Can any of you think of it? When you go to an ATM and you want to take out money from your ATM, okay, after we've assumed subtraction, right? Yeah, we need to subtract something from the balance. But what something? What something? Okay, yeah, so I think probably you guys get it now. We'll need something to an amount to deduct, right? Like the amount that the person wants to take out. So this is just going to take in one variable called amount. That's a double, and it's just going to be the amount that we want to deduct from our balance, the amount of money that we want to take out of our account. Okay, and yeah, then it's just a simple if statement, right? What do I need to confirm about the amount? Yeah, what do I need to confirm about the amount in order to make this transaction? What's the first thing that comes to mind? Right, Jane has 10,000 in her account. She calls the debit account function method. What does the debit account method have to do? What does it have to check? Before it just gives Jane money. So if Jane says, hey, I want to debit 11,000, what is the debit account method going to say? If she has enough to remove. Exactly, it needs to check her balance. It needs to make sure that the amount she's withdrawing isn't larger than her balance, right? That makes sense. What statement would we use to check that, guys? What statement would we use to check that? Anyone know? Because there's a few different ways we can make decisions, right? We saw two of them. If. Exactly, that was long ago though. So, precisely we'll use an if statement to make the decision, right? And you can even see it in the question, right? We're saying if she has enough to remove. Precisely, right? If. Okay, it's an if statement. Cool, so that's a pretty simple if statement, right? All I'm checking is if, okay, amount is the amount that I want to withdraw. So I'll just say if amount is less than the balance is the amount we have in the account, right? So if the amount is less than the balance, then I'll say balance equals balance minus amount, right? To remove the amount from the balance. And then we're done. That's our function. Okay, otherwise we do nothing. Okay, we could also print out like not enough money or something. Okay, I'll do that as well. So I'll say else console.writeLine not enough money. Okay. Cool. So, shall we try this out now? Okay. Cool. So remember what we're discussing here. We've programmed this system now, right? It's pretty simple so far, but we've programmed this system, and all it does is checks if the amount is less than the balance, then it will subtract the amount from the balance. Okay, pretty simple so far, and otherwise it tells you that you don't have enough money. Okay, pretty that's what you would expect from a bank thing, right? A debit method. Okay, it doesn't have to do anything more complicated than that. There's other methods that would handle, actually giving you the money at the ATM or something like that. Okay, so we need to test this out. Okay, we want to test this out. So what we're going to do is write a single unit test. And why I want you to see that this is what we would call a unit test is there's a lot of other stuff happening at the bank, right? Like you need to make sure that the names are correct. You need to make sure that the interest is added correctly. There's so much stuff happening at a bank, right? Like what if there's a credit system? What if there's, it's like there's infinitely many things, like little things that you would have to do, okay? This is just one method, one simple method, right? We're not discussing how she deposits the money, making sure that the balance updates correctly when you add money to the account. None of that stuff we care about. We care about our one little silly method, okay? That is a single unit of code, right? That method there. So we're just testing that, and so we call that unit testing. So I want to show you what one unit test would look like and how we would do it. We'll do that in the last 10 minutes, and then we'll finish off testing next week's lecture. Okay, so how we'll create a unit test is we create some initial conditions, all right? So we'll say initial equals, currently we're working with 10,000. I'm happy with that amount. Okay, so this is going to be a double, all right? So what I want you guys to see is that we're creating a bunch of variables that will allow us to run tests. Okay, so initial. Okay, so we open up the account with an initial value of 10,000. Okay, that's what our constructor there is doing. All right, so I hope you see that. We then need an amount to withdraw. Okay. Let's say we're going to start by withdrawing 9,000, just to test. It's one unit test. Remember, we could have multiple unit tests, lots, hundreds. Okay, this is just one unit test. Okay, and then we need, what do I need here, guys, to test if this worked correctly? What will I do? How would I know if my system here worked correctly? Okay, so I have an amount. I'm writing a single unit test. Okay, I have an initial amount. I have an amount to withdraw. Okay. How would I know? How would I be able to check after I use the debit account function? How would I be able to check if my method actually worked? You could print out the balance, but ideally I would want to compare it somewhere else, right? But you're thinking along the correct lines. I would say I would print out the balance after the account has been debited. And what would I expect it to be in this case? If my account was initially that and I withdrew 9,000, my account was initially 10,000, I withdrew 9,000. Exactly, I want it to be 1,000 afterwards. Okay, so what we're going to do is create another variable saying double expected. Okay, so this is the result that we expect to get back when we debit the account. And now we can actually write the unit test itself. So we open up an account with the initial value. Then we would say ACK. So ACK is our object, right? Inside our ACK object, we have the debit account method. So I'm going to say .debit account. Okay. And I'm going to debit the amount, right? I want to debit the amount variable. Okay. I want to debit the amount. Okay. And then the next thing I have to check is so I'll say double actual equals ACK dot. How do I get the balance, guys? How am I going to get the balance from the thing? So you said, yeah, precisely. We will kind of be doing white box testing because we know how the code worked, right? We know how the code worked. I know how to break it. Okay, so we're gonna test out a few cases and see how this works. But so Ham says balance, but remember to access the balance is inside the accounts object, right? It's called balance, but in order to actually get it, I have to call the getter, so capital B. Okay, so we say ACK.balance to get the balance. So we debit the accounts. I then say this actual variable holds the actual balance, the account dot balance after the debit account method is called. Okay. Now, what do I want to check here, guys? I've got the expected balance and the actual balance. What do I need to check? What statement will I use to compare these two things? What operator would I use? Do any of you even remember the operator that I would use here? How do I make sure? How do I compare my expected and my actual? What am I doing here? Ooh, you're going as far as I comparable. I mean, I like that. I like that you're thinking out of the box. Remember, these are just two numbers though, right, Saham? I have double expected and double actual. How do I compare these two things? In just this unit test. Remember, I'm just comparing these two. Doesn't need to work for all objects. Is it equals? What does the equal sign do? Equals equals. Good stuff. And so that's the operator I'll use, and it'll be inside an if statement, right? So I'll say something like if actual equals equals expected. Okay. If that's true, that means the balance, the actual balance after I debited the account was the same as what I expected it to be. So that means I passed the test, right? So I can say debit unit test. I'll say console.writeLine debit unit test passed. Okay. And if that's not the case, if the actual was not the same as the expected, then we can say, oh, I must put a semicolon there, sorry. And then we'll say console.writeLine debit unit test failed. Okay, so when I run this, you can see it prints out debit unit test passed, because our debit account method seems to be working for that case. Remember, we just tested one case where we tried to withdraw 9,000, and it worked for that case, right? We could try a bunch of other cases. All right, so we're happy with that, hopefully. Cool, I see Johnson also got equals equals, that's good. Okay, so you see that's how we do that. Right, let's try out some other cases. I happen to know, because of how we programmed this method, that this is wrong. Okay, guys, so what I want to ask you is amount. What are we thinking about here? Can amounts hold negative numbers currently? It's a double, right? So how do you think this might be broken? Let me show it to you this way. Let's do a little example here. If we say, because remember, I just programmed this because I wanted to see, like, I want you guys to see why testing is important. It seems like this works, right? We try it with 9,000, a positive number, and it seems to work pretty effectively, right? It debits the accounts, and we get what we expect afterwards. What would happen here if Jane decided to withdraw negative 100? A double can hold negative numbers, that's true. So look at this method here. Let's say Jane said, hey, I'm drawing negative 100. What would this do? Well, it would come in, it would save negative 100 in amount. It'll say amount, which is minus 100, is less than balance. That's true. Negative 100 is less than 10,000, is it not? Then it's going to say balance equals balance minus 100. What would that give? It'll say minus 100. That's bad, right? It'll say minus 100, which would mean that we just gave her an extra 100 Rand, so Jane could generate infinite money. Okay. So this debit account method, although it's very simple, and maybe all of you guys were convinced that it works, the reason we do unit testing is because code is very difficult to verify. Okay, there are lots of little cases. So what I'm going to show you is, look, initial was 10,000, right? I'm going to say amount we withdraw is minus 1,000. Okay. if our code was working. So I'm asking you, if our code was working perfectly, what would we expect to happen? If you had 10,000 in your account and you tried to withdraw minus 1,000, negative 1,000, what would we expect to happen if our code was working, guys? What would the result be? If our code was working, what would you want it to be? You would want the unit test to fail. But what I'm saying is, what would you want the balance to be after that worked, after that ran? You would want the balance to not have changed, correct? Like if you had 10,000 in your account and you tried to draw minus 1,000, it should say that's invalid. That's an invalid amount. Okay, so what we would expect is for our balance to still be 10,000.0, right? So our balance was initially 10,000. We tried to withdraw minus 1,000. We want it to still be 10,000. And you'll see when I run this, it'll say debit unit test failed. Why did it fail? Because our actual balance after this ran was 11,000. Okay, was 11,000. So this unit test allowed us to see that our code was broken. Okay, and we had to fix it. And we have to fix it. And that's why we do unit testing. Okay, so what is unit testing? It's testing the smallest components of your code, each method individually. Okay, each method, each little thing that you do, you test each of those individually. Okay, there are 4 other levels of testing. We have run out of time this week, so we can't discuss them now, but we will discuss them next week. Okay, you've actually already read about them if you did the extra reading. So I'll give you guys maybe a bit of a break this week, and yeah, we'll continue with this stuff next week. So thank you for coming, guys. If there's any other questions, please remember I sent the exam registration form on the WhatsApp group. Please fill it out. I'll post a reminder on WhatsApp after this as well. Okay, but otherwise, yeah, we are done for today, and I'll see you next week, same time, same place. Yeah, it's a pleasure. Yeah, see you guys next time. I'll remember to mark the rest of you who came off on the register. Cool. Cheers, guys. I'll stop recording and finish.